Hi everyone, and welcome to the MAT 211 review of More Probability. My name is Julia, and I work for the tutoring centers at ASU. So suppose that the keys of a typewriter, which contain 26 letters and a spacebar, are hit at random. What is the probability that the first 22 characters are the phrase "finite math can be fun," and including the spaces? So first thing to note is that we're including the spaces, so the whole number of characters here, including spaces, is 22. So we have 22 separate events here. Now, the probability of each key being hit in order to form this phrase doesn't change based off of any other keys that were hit. This may not be really true of like normal typing, but in this case, we're assuming that these keys are hit at random. So that means because they're hit at random, they're independent of each other. So therefore, the total probability of this whole phrase happening is the product of each individual probability. So let's think about what each individual probability is. We want one event, so let's consider like this first F here, the probability of F, hitting F on the first key. So we know that there is one way that could happen over 26 letters plus a space bar, so 27 different keys that could happen. So the probability of hitting F at any given occasion is 1 over 27. Now this is going to be true for any key in here because we're assuming equal probability for all of these. So then the total probability is going to be of like all of these letters is going to be the product of all the probabilities of each individual letter as we go through this. I'm just scribbling out all over this. So since there's 22 of these, we would have like 1 times 27, or 1 divided by 27 times 1 divided by 27 times ... And we would have 22 different terms in our product here of 1 over 27. So this is going to be, we can rewrite this as 1 over 27 to the 22nd. And this is the probability of our phrase. Finite math can be fun. Now, this produces a really, really tiny decimal. It has a whole bunch of zeros in it. So rather than show it as an approximate decimal place, because I'd have to write, zeros all the way across the screen, just note that this approximately equals the scientific notation of 3.2359 times 10 to the negative 32nd. So very, very small probability, but not zero. So let's put a little box around this because this is our solution. And before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, you can visit the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Additionally, if you're looking for tutoring services for your specific course, you can use the tutor search tool, which you can find on our main website here, or by going directly to it at this full link. So thanks so much and have a great rest of your day.